Hello everyone, and welcome back to Mitchell's Physics Review. Today we're looking at rotational dynamics. Let's look at our question. A potter's wheel, a thick stone disc of radius 0.5 meters and mass of 105 kilograms, is freely rotating at 50 revolutions per minute. The potter can stop the wheel in 6 seconds by pressing a wet rag against the rim and exerting a radially inward force of 76 newtons. Find the effective coefficient of kinetic friction between the wheel and the rag. First, let's look at our givens. We know the normal force is 76 newtons, the radius is 0.5 meters, the mass is 105 kilograms, the angular velocity is 50 revolutions per minute, and the change in time is 6 seconds. With what we know, and we know that the object is coming to a stop, we can find out the change in angular velocity through the final angular velocity minus the initial angular velocity. Since we know it's going to stop, it's at 0, and we know it's initially at 50 revolutions per minute. So we're going to subtract the two and get that the change in angular velocity is negative 50 revolutions per minute. Next, we can look at our torque diagram. We have the normal force pointing inwards or radially inwards towards the center. Then we have the frictional force pointing the opposite direction of the rotation because we know that the frictional force is what's going to bring it to a stop. So, that's all for our conceptual. Now, let's move on to the mathematical portion. Now, we are going to use the equation net torque equals moment of inertia times angular acceleration. Well, why not net torque is equal to 0? Well, we need to examine the forces. A frictional force is a non-conservative force, meaning that this system is not in equilibrium, so we cannot say that the net torque is equal to 0 for this problem. That's how we know what equation to use. Now we know that since the normal force is inwards, we're not going to use it because we're only going to use the perpendicular forces to point. So we know we're going to need Fk, and since it's the opposite of which way the rotation is, it's going to be negative. So negative Fk times the radius equals the moment of inertia. The important part for this is that it's a stone disk, so the moment of inertia for a disk is 1/2 mr squared. Now, angular acceleration. Well, we don't have that, so we have to put it in terms we do have. We have the change in angular velocity and the change of time, so we can replace angular acceleration with those quantities. Now we need the coefficient of kinetic friction. Well, how do we get that? We know that a frictional force is equal to the coefficient of that frictional force times the normal force. So that's where we can substitute in mu k times Fn times the radius equals the moment of inertia times the angular acceleration. Finally, we can simplify the equation to make mu k equal to negative mass times radius times change in angular velocity all over 2 times the normal force times the change in time. From there, we can plug in our numbers. So, once you do that, you plug it all into your calculator, and we're going to get mu k equals to 2.878. But we are not done there. No. First, we have to convert into radians instead of revolutions. To do this, we're going to multiply by 2 pi. Next, we have to convert into seconds from minutes to seconds. So we're going to divide by 60. And finally, we're going to get the coefficient of kinetic friction is equal to 0.301. So, overall, what I really struggled with this unit, or this problem at least, is when I saw angular acceleration, I was lost. I had 2 unknowns in my equation, and I could not figure out what was going on or what I was supposed to be plugging in. So the important part to take away from this, and from what I've taken away from this, is look at the quantities we do know and see what we can substitute in. For example, we could figure out the change in angular velocity, and we did know the change in time. And it's also similar with the frictional force. I was confused because I was like, where does Fn come in? Where does the coefficient of friction come in? Well, I had to take a step back and go back to what I've already learned. I know what Fk is equal to. The biggest takeaway I have, and I hope you had, is that you realize we have to look at our given quantities first, and we have to look at this conceptually before we start plugging in numbers, because it's easiest to see what we know and solve the unknowns from there. I hope you learned a lot from this video. Thank you.